appeared or moving rod measured basically shorter. This is the concept. So you have to always try to figure it out. What will be relative speed along the length of rod? So this is one of the very fundamental thing. Okay. So let us try to go for one more question. This is very interesting one. So there is a earth, and let's say this is your earth. And with respect to earth, and this type of question has come into last year either in TIFR or JEST exam. So I am just, so there is a one rocket A is moving with velocity u, and another rocket is moving B, moving with velocity v towards A. So both are given with respect to earth. So velocity of A with respect to earth is u, you can say, and velocity of B with respect to earth is basically, you can say, minus v. Both are in I cap direction. Okay, so there is not any problem. So, and the distance between them when they have just started to shoot out, that is basically L naught. So this is your distance. What we have to do, we have to calculate time measured by observer, attached to B such that both rocket will collide. So this is wonderful problem. Okay. So what we have to do, we have to just try to see when we are going to sit on B, what will be time measured by observer such that these two rocket is going to collide. This is very interesting. So now, first of all, what will happen when observer will sit on B? If observer will sit on B, then what will happen? This is the scenario measured by the observer who is sitting on Earth. If this observer will see the whole scenario, this is something like this, which is given in our problem. But when observer will sit on B, then what is going to happen? When observer will sit, sorry. When observer will sit on B, then this A will move with what velocity? This A will move with what velocity? Velocity of A with respect to B, isn't it?
Yes, sir.
Yes. And what will happen to this particular B particle?
It will feel like it is in rest.
It will remain rest. It will remain rest. When the observer will sit on B, then this scenario is going to happen. And now, what is going to happen to this particular length? What is going to happen to this particular length? This length will appear to this observer as a stationary or moving. Moving. In which direction? In which direction? In positive direction. With what velocity? V in I cap direction. So sorry. So this is the scenario that going to happen with respect to this particular observer when observer is sit on B. So here is your observer. Observer is sitting on B. So this scenario is given. Okay. So now, and this is my Earth. So this is my Earth. So now just tell me, is that this particle will travel L naught distance or less than L naught distance?
Less than L naught distance.
Less than L naught distance. So what will be new distance? The new distance will be contracted one with what velocity?
With v velocity, sir.
With v velocity, isn't it? So this is going to contracted one with velocity v, because if you are sitting here, you will, this length is appear to move with velocity v. So this will be L naught root under 1 minus v square c square. So with respect to this observer, this particular A, so this A rocket have to travel this much of distance. So what will be time measured with respect to B? So time measured with respect to B is given by what? Distance by velocity, isn't it?
Yes,
So
sir.
what will be distance?
L.
L. And what will be velocity?
VAB.
AB.
Velocity of A with respect to B. So now the whole challenge is that we have to calculate velocity of A with respect to B, isn't it? And we have to take just a magnitude. Okay, we have to take magnitude, nothing to do with the negative sign. So this will be your answer. So now let's try to calculate velocity of A with respect to B. So what will be my S frame?
B.
B is my S frame. What will be my particle?
A.
A. What will be my S dash frame?
Earth.
Earth is my S dash frame. Now let's try to go for it. Velocity of A with respect to Earth is equal to V I cap. So velocity of Earth with respect to A. So this will be, sorry, velocity of A is U, na? So this is U. That will be minus U I cap. Velocity of B with respect to Earth is minus V I cap. So velocity of Earth with respect to B is V I cap. Now we can put, what is my S frame? So again, we can put all the codes. So what is my code? A is my S frame. Sorry, B is my S frame, na? What is my S frame? B is my S frame. What is my sigma? S dash. So here you can have sigma, or Earth is my S dash. So this will be S dash, this will be S, this will be S dash, this will be particle, this will be particle, this will be S dash. So what we have to calculate? We have to calculate velocity of A with respect to velocity of A with respect to B. That means first we have to calculate velocity of A with respect, so this will be velocity of S with respect to particle. So we have to calculate ux, uy, uz, mainly ux you have to calculate. Now, which term we are going to take? What is this one?
UX dash.
Ux dash. So here we can use ux dash is equal to u. What is your velocity of S dash with respect to S?
Yes.
What is that?
V I cap.
V I cap. So this will be your V. And we have to calculate velocity of particle with respect to S is equal to velocity of particle with respect to S dash plus velocity of S dash with respect to S, 1 plus velocity of particle with respect to S dash with respect to S upon C square. Okay. So this is, ये दिखाई दे रहा है आपको? Okay. Good. So now what will be velocity of particle with, or velocity of A with respect to B is equal to U plus V 1 plus UV upon C square. So what will be this particular value? What is TB? L naught root under 1 minus V square upon C square upon, this will be U plus V 1 plus UV upon C square. So this will be time measured when observer is sitting on B. Now, what is going to change is if observer is sitting on A, क्या change हो जाएगा? Is that this value is going to change?
No, sir.
Huh? The magnitude of this value is going to change or remain same?
Same है.
Same रहेगा. जो इसके रिलेटिव में इसकी वेलोसिटी होगी वही इसके रिलेटिव इसके रिलेटिव में जो इसकी स्पीड होगी वही इसके रिलेटिव में इसकी स्पीड होगी. आई एम टॉकिंग अबाउट स्पीड मैग्नीट्यूड. ओके, इज दैट दिस विल रिमेन सेम और डिफरेंट?
So different.
दैट विल बी डिफरेंट. या v की जगह पर क्या आ जाएगा?
U.
U.
u आ जाएगा. ओके, सो यू हैव टू ऑलवेज टेक केयर दैट वेयर इज ऑब्जर्वर एंड व्हाट इज गोइंग टू ऑब्जर्व. ये बहुत ही ज्यादा इंपॉर्टेंट है कि ऑब्जर्वर कहां बैठा हुआ, वो कैसे ऑब्जर्व कर रहा है. आर यू गेटिंग माई पॉइंट?
Yes, sir.
है ना? सो दिस इज वेरी इंपॉर्टेंट प्रॉब्लम.
सर,
और इसको आपको हाँ बताइए.
एक बार क्वेश्चन की स्टेटमेंट क्या थी?
स्टेटमेंट ये था कि अगर ऑब्जर्वर बी पर बैठा हुआ है तो वो कितना टाइम मेजर करेगा सच दैट ए इज गोइंग टू कोलाइड विद बी.
ओके सर.
ठीक
सर
है.
उसमें दिया हुआ था, मतलब ये पूछना था कि उसमें दिया हुआ था कि हाँ बी पे ऑब्जर्वर है.
हाँ, इफ ऑब्जर्वर इज सिट ऑन बी देन व्हाट विल बी टाइम मेजर्ड सच दैट बोथ आर गोइंग टू कोलाइड.
ओके सर.
अगर ऑब्जर्वर ए पर होगा तो फिर क्या चेंज आएगा बताओ?
सर ये वेलोसिटी अराउंड द लेंथ.
कॉन्ट्रैक्टेड लेंथ होगा. अगर ऑब्जर्वर अर्थ पर ही रहे तो क्या देखेगा?
अर्थ पे तो प्रॉपर लेंथ ही आएगी ना सर.
प्रॉपर लेंथ ही आएगी. वेरी गुड. सो आप यहां देख सकते हो इफ ऑब्जर्वर इज एट अर्थ एंड प्लीज रिलेटिव वेलोसिटी तो दोनों हर जगह से सेम ही रहेगा, है ना? रिलेटिव वेलोसिटी विल ऑलवेज, द मैग्नीट्यूड ऑफ रिलेटिव वेलोसिटी विल ऑलवेज रिमेन सेम. तो हर केस में दिस टर्म इज ऑलवेज रिमेन सेम. व्हाट इज गोइंग टू चेंज? दिस टर्म इज गोइंग टू चेंज, इजंट इट? समझ में आ रहा है? कोई डाउट है तो पूछ सकते हो, अदरवाइज वी विल गो फॉर नेक्स्ट प्रॉब्लम. Okay. Now, next question is very interesting. So there is a frame A and the rod is rest on the frame A with proper length L naught. Sorry. This rod is rest with respect to frame A. The proper length is, and this is along x-axis. Okay. Proper length is L naught. This A is moving with respect to B with velocity c by 2. And this B is moving with velocity c with speed c by 4. Now question is that what will be length of rod measured with respect to A? What will be length of rod measured with respect to B? What will be length of rod measured with respect to C? And it is given velocity of A with respect to B is c by 2. Velocity of B with respect to C is c by 4. So now we have to calculate all these three things. Now just tell me what is going to happen. So first का आंसर क्या होगा?
L naught.
L
L
naught.
naught. So this will be L naught. Why L naught? Because this rod is rest with respect to A, then obviously the observer who is going to attach with A in the rest frame of rod, so he will measure proper length. Now, next will be the length of rod with respect to B. So what will be speed of rod with respect to B?
C/2.
C/2. So you have to just write L naught 1 minus velocity of rod with respect to B whole square C square along the length. So you have to always take care of along the length. Okay. So this will be L naught root under 1 minus, what is this value? The velocity of rod with respect to B क्या होगा? That is what? C/2. So that will be 1 by 4. So this is L naught root 3 by 2. Now, what will be length of rod with respect to C? अब इसके लिए हमें क्या करना पड़ेगा? You have to calculate. So length of rod with respect to C. What will be proper length? Proper length क्या होगा?
But the one that is lying in between.
What is proper length? L naught. L naught will be proper length because proper length is uniquely defined. So it will not depend on which reference frame you are. So for every reference frame, proper length is same. Okay. So this is L naught 1 minus velocity of R with respect to C mod square. So now the whole challenge is we have to calculate velocity of rod with respect to C. That means we have to calculate velocity of A with respect to C. Okay. So what will be my, so we have to calculate velocity of A with respect to C. Once we can easily calculate, we can get the answer. So what is my S frame?
C.
C is my S frame. What is my particle? A is my particle. So B will be my S dash. So what is velocity of S dash with respect to S? क्या होगा जरा बताइए? यहाँ तो डायरेक्ट पता चल रहा है.
C/4.
C/4. So this B is what? Your S dash. C is my S. So you have, this is equivalent to velocity of B with respect to C. That is C/4. You have to calculate velocity of a particle with respect to S dash. So this will be your S dash. This will be your particle. So in this type problem, you can easily use this thing. So that is equivalent to velocity of A with respect to B. This is nothing but what? Ux dash. And this will be C/2. And this is nothing but your V. Isn't it? जो हमारा original notation है. And Lorentz transformation किस direction में होगा? That will be in I cap direction. So velocity of A with respect to C is basically, we can easily use Ux, and this is nothing, Ux dash plus V, 1 plus Ux dash V upon C square. So what is this value? देखो तो कितना कैलकुलेट करके आता है? C/2 plus C/4, 1 plus C/2, C/4 by C square. 2C/3 आता है क्या?
Yes, sir.
हम लोगों ने ये प्रॉब्लम किया भी था, याद है? A के रेस्पेक्ट में B, B के रेस्पेक्ट में C, ऐसा किया था. फर्स्ट प्रॉब्लम ऐसा ही किया था, याद है ना? उसका अब एप्लीकेशन देख रहे हैं. So yes, this value is 2C/3. So now what is of length of rod with respect to C is nothing but proper length into relative speed of the length of rod with respect to observer, and that value is equal to what? 4/9. So this is L naught root under 5/3. Okay. Now what is the second one? Second one का आंसर क्या है? L naught C/4 क्या है?
3.
√3/2.
2.
Okay. Now अब मेरा एक क्वेश्चन है कि which observer is best observer? या फिर सारे ऑब्जर्वर सही हैं, या फिर कोई एक ऑब्जर्वर ही वो बेस्ट है?
सारे सही है।
सारे सही है ना? बिकॉज वेन एवर यू वॉन्ट टू चेक whether others result is correct or not, you have to go on to his reference frame. Once you will go to his reference frame, then you will the measure same thing. What is what will that person is going to measure? Suppose if you want to check whether A is correct or not, you will be at A, then you will measure this is proper length. If you will measure with whether B or correct is not, you have to shift towards yourself to B, then obviously you will measure something like this one. And when you will go for C, you will measure this one. Okay. So all observer are correct. So why we can say there is nothing called absolute frame. The frames are always relative in nature. Nothing called absolute frame. Absolute frame जैसी कोई भी चीजें नहीं होती है. ओके, यहां तक क्लियर है?
सर
ओके. सॉरी. So let's go for one more problem. This is very interesting. Let's try to go for this. So there is a frame. Let's say this frame is sigma. And one rod has proper length L0 and another rod has proper length 2L0. Let's say this is A and this is B. So this problem was asked in your JAM exam also. Okay. So this is your A and this is your B. Both rod is moving in opposite direction. So you can move in opposite direction with respect to sigma. So velocity of A with respect to sigma is V I cap. Velocity of B with respect to sigma minus V I cap. The first question is that what will be, ऐसे लिखो, if observer will attach to, if observer will attach to sigma, what will be value of V such that length of B appeared him L0. So this is first question. This is very trivial. ये एग्जाम में नहीं आया था. एग्जाम में सेकंड क्वेश्चन आया था, which is very interesting. What is your second question? If observer will attach to rest frame of A what will be value V? I am talking about magnitude. What will be value V such that length of B appeared him L naught. Length of B appeared him L naught. ठीक है? So this is very interesting one. और आप देखो इसको कैसे सॉल्व कर सकते हो. So first के लिए क्या करेंगे? What we have to do for first one? फर्स्ट के लिए आपकी प्रॉपर लेंथ क्या है? हमें बी का लेंथ देखना है ना?
Okay, yes sir.
तो प्रॉपर लेंथ ऑफ बी इज
2L naught.
proper length of B is equal to what? 2L naught. Okay. So proper length of B is 2L naught. Now B का लेंथ हमें क्या होना है? L naught
L
मिलना
naught.
चाहिए, है ना? With respect to what? Sigma. वाला क्वेश्चन तो यही दे रहा है. So length of rod with respect to sigma must be equal to proper length. What is proper length? 2L naught and 1 minus velocity of rod with respect to sigma square upon c square. Isn't it?
Yes sir.
है ना? एंड ये लेंथ आपको क्या नजर आनी चाहिए यहां पर आने के बाद?
L
L
naught.
naught.
L naught. So this is a straightforward question. So this is 2L naught 1 minus, and what is velocity of B with respect to sigma?
Minus B.
Velocity is minus V, but you will take the magnitude part. So that is what? V square upon C
C
square. So from here, you can easily calculate 1 by 4 is equal to 1 minus V square upon C square. That means V is equal to what? Root 3 by 2C. हो रहा है क्या?
Yes,
Yes
sir.
sir.
So this is very trivial. 1 marks के questions हो सकते हैं आपके पास, है ना? Okay. But next question is very interesting. Next question में ये फॉर्मूला कैसे चेंज होगा? How we are going to change this formula? So length of rod with respect to now what?
A.
A.
What will be proper length?
L naught.
L naught. L naught or 2L naught?
2L naught.
2L naught.
2L naught. हमें इसका चेंज करना है ना? B का चेंज करना है. Okay? You have to sit on A and you have to see what will be velocity V such that its length will be L naught. So proper length will remain same for every observer. And here we have to use 1 minus velocity of rod with respect to A square upon C square. And what should be this value? This value should be what? L naught. Okay. So this value 1 minus V square R A upon C square. Now the whole challenge is what? पूरा challenge क्या है?
वेलोसिटी निकालना
VRA.
Velocity of rod with respect to or velocity of B with respect to A, है ना? Rod is B. मैं यहाँ पर मैं rod कह रहा हूँ. That means I am talking about B. So let's try to calculate velocity of rod with respect to B. यहाँ तक clear है ना?
Yes sir.
Okay. चलो निकालते हैं. So आप देख रहे हो that relative velocity is very important, है ना? So everywhere you can use this type of concept. Okay. So what we have to do? We have to calculate velocity of B with respect to A. Okay. And what is given? The given is velocity of A with respect to sigma is V I cap. So velocity of sigma with respect to A is minus V I cap. Here, velocity of B with respect to sigma is basically minus V I cap. Velocity of sigma with respect to B is plus V I cap. What is my S frame? What is
A.
my S frame?
A.
A. S frame क्या होगा? S frame is A. What is my particle?
R.
B.
R.
R means rod. Yes. R or rod. B. Yes. Good. What is my S dash frame? Sigma.
Sigma.
So this will be my S dash. 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 B is my particle. B is my particle. A is my S. A is my S. Now, अब इसमें आपके काम की कौन कौन सा इंपॉर्टेंट है आपके काम के लिए कौन कौन
माइनस वी आई
इंपॉर्टेंट है
माइनस वी आई
माइनस वी और माइनस वी है ना सो वेलोसिटी ऑफ एस डैश विथ रेस्पेक्ट टू एस इसे आप क्या कहते थे वी कहते थे यहां पर मैं क्या ले रहा हूं इसे माइनस वी ऐसे लिखने से कंफ्यूजन हो जाएगा इन आई कैप डायरेक्शन नाउ वेलोसिटी ऑफ particle with respect to s dash is what ux dash and that value is what कौन सा लोगे
I cap.
कौन सा इसमें फर्स्ट सेकंड थर्ड फोर्थ
Third.
third one so that will be minus v in I cap so now velocity of a particle with respect to s velocity of a particle with respect to s dash velocity of s dash with respect to s 1 plus velocity of s dash with respect to s into by c square so if we are getting all this number then what we have velocity of a particle with respect to s क्या आ जा रहा है so this will be minus 2v and you have 1 plus v square upon c square yes
Yes, sir.
clear है ना now यहां तक तो ठीक है but when you are going to solve this particular problem I am just giving you as a homework कि आप इसको कैसे solve करते हो so just try to solve it because it is very important that you have to stick on the correct calculation okay so what will be your final answer your final formulation is what L naught is equal to 2L naught root under 1 minus 4v square and this will be 1 plus v square upon c square whole square by c square isn't it होगा ये and now you have to just calculate the value of v यहां से calculate कर लोगे
यस सर
है ना so you can easily calculate this thing now what will happen the real challenge जरा real challenge देखते हैं हम लोग what is real challenge take a square both sides so we have 1 upon 4 is equal to 1 minus 4 v square upon c square into 1 plus v square upon c square का whole square isn't it ऐसा ही है ना so when you are going to solve it that will be fourth power of v isn't it होगा ना इसे जब आप करोगे तो क्या होगा that will nothing but what fourth power of v so how you will solve it इस तरह के प्रॉब्लम को कैसे सॉल्व करोगे anyone
Sir, we can take it in the upper side.
you can
Minus-
obviously you have to take it upper side and there is this thing is
No, no.
also there
Sir,
Huh.
1 plus v square by c square to the power
Huh.
minus 2. Then
To the-
Taylor expansion.
Taylor expansion no don't do Taylor expansion why you will do Taylor expansion
is equal to t.
we have to completely solve it
Consider v square is equal to t.
so you have to consider v square upon c square is equal to alpha okay so when you will put v square upon c square is equal to alpha so 1 by 4 1 minus 4 alpha by 1 plus alpha whole square okay now you can easily solve it okay and I think the alpha will be c upon root 3 will be answer okay just try to solve it I think this will be answer c upon root 3 are you getting my point है ना so now this is quadratic in alpha So you can easily solve quadratic equation. So in JAM examination, they have asked this question. So lot of people have stuck at this point. Okay. So don't do unnecessary Taylor expansion or other thing. You have to just go for a straightforward, a logical calculation. Okay. So this type of question will always come into your exam. है ना? इस तरह के क्वेश्चंस आपके एग्जाम में आएंगे. And I will stop your class here. Tomorrow we will go for what? Time dilation. ठीक है? Because I have little bit throat infection. So कल हम लोग इसे पूरा करेंगे. ठीक है?
Yes, sir.
Okay. So just try to do practice and you have tutorials. है ना? आपके पास STR के 2 tutorial होंगे. So you can start your to solving the tutorial 1. So tutorial 1 के first part is the Lorentz transformation. Second part is the relative speed, and third part is the length contraction. So today you have enough time, so you have only one class. Then please try to solve your tutorial 1 and part A, part B, and part C. Okay, just try to solve it.
Okay. Thank you, sir.
Most of the question we have solved, but you have to solve with yourself. Okay, so just try to solve tutorials and previous year questions for up to relative speed and length contraction and Lorentz transformation. Okay.
Yes, sir.
Okay. So tomorrow I will continue with the time dilation. Okay.
Thank you, sir. Good
Thank
night,
you,
sir.
sir.
Good night.
Thank you, sir.
Thank you, sir.